Hi everyone, my name is Victoria Carthew and I'll be guiding all the upper primary students through their learning today. Coming up, we'll be looking at multimodal texts in English. We'll be solving problems on a number line in maths and we'll be looking at the solar system in science. So this is the time to make sure that you're feeling focused and comfortable, get your thinking caps on and let's get ready to learn. Many of the texts that we read and engage with are multimodal texts. This means that they are created using a combination of two or more communication modes, like print images and spoken texts. Today, let's explore some different types of multimodal texts, and let's look at how they're structured to engage the audience.
Hi everyone, I'm Rebecca, and today we will look briefly at what multimodal texts are before examining the structure of some of the multimodal texts you might read or engage with throughout your day. Before we consider what multimodal texts are, it is helpful to think about the way that we communicate ideas with other people. We use a variety of modes or ways to communicate ideas and messages. We communicate through speech, writing, signs, images, and pictures. All of these different ways of communicating can be used to create a multimodal text. Multimodal means a combination of words and pictures, or words, pictures, and sounds. A multimodal text is created when we combine two or more modes or ways of communicating. Can you think of some of the texts that you have read or viewed that would be multimodal texts? You may have thought of a whole range of different texts, including picture books, daily cartoons, comic strips, and comic books and graphic novels, where the author uses written text and images. You may have also thought of stop-motion animation movies, computer animation movies, and televised news reports, where the author uses moving images and audio, including dialogue and sound, to convey meaning and tell a story. Like all texts that we engage with, a multimodal text will follow a particular structure and include certain features that are relevant to the type of text it is. For example, a picture book will follow the structure of a narrative. Let's have a closer look at this using some of the multimodal texts that you might like to read for fun. To do this, we are going to look at daily cartoons and comic strips. A daily cartoon is a sketch or drawing that is usually funny and is often found in a newspaper. There is no sound and the images do not move. A comic strip is a sequence of drawings, usually in a horizontal strip, either in colour or in black and white. It can be funny or could be a mystery or an adventure. Comic strips are often in a series and use speech and thought bubbles. There is no sound and images do not move. To write a good multimodal text, an author will think about the purpose of the text, who it is written for, and what type of text is being written. That is it a comic, a news report, or a movie? Let's think about the way the multimodal texts we are looking at are structured and their features. So what are the language, visual, and audio features used in daily cartoons and comics? Language features in comics and cartoon strips include speech in speech bubbles, thoughts in thought bubbles, and some narration in boxes. Visual features are very important in cartoons and comic strips and include illustrations and computer-created characters. The types of visual features include colour and tone, which is used to show the different characters. The villain is often drawn using dark colours and shadowing, while the hero is drawn using light colours and brightness. Size and placement is used in comic books to show the importance of main characters. The most important character is often placed in the foreground or the front of the picture, and less important characters are often placed in the background. Speech and thoughts are shown through the use of size, bold letters and italics, and sometimes the shape of words. Facial features, that is the features on the faces of the characters, for example, eyes, eyebrows, nose, moustache, chin, and tone and pitch of words, is often shown through the use of size, bold letters or italics, and sometimes the shape of words. These features help achieve the purpose of a multimodal text. What do you think the purpose of a daily cartoon or comic strip is? You probably thought that the purpose of both of these multimodal texts was the same. They are designed to entertain the reader. Do you think all multimodal texts will have the same purpose? Not all multimodal texts will have the same purpose, as they'll be created for a variety of reasons. Some multimodal texts, for example, will be designed to inform or persuade the audience. The purpose of the text can influence the structure the multimodal text takes. The text structure for these two multimodal texts is a bit different. The daily cartoon is just one single event. Something is happening at a point in time. It's not a story as such. The comic strip follows part of the narrative structure. Normally, you won't see the whole narrative structure, so the orientation, complication and resolution, in one comic strip, as they're often written as a series. You read one comic strip on one day and it continues on the next day. We are now going to look at our two multimodal texts and think about their features and purpose and how effective they are at engaging the reader. We'll begin by looking at our daily cartoon, Lionel's Transfer. Take a moment to read the daily cartoon. You can see that in this daily cartoon we have a picture of a lion who looks a bit fancy and well groomed, sitting on a rock and holding a set of clippers or a trimmer. He is surrounded by a pride and is asking them where he can plug in his trimmer. The caption under the cartoon reads, "Lionel's transfer from Taronga Zoo to the plains of Africa had run into a problem." What language, visual and audio features are used in this cartoon? Remember, this includes things like speech in speech bubbles, thoughts in thought bubbles and some narration in boxes, colour, size and placement of drawings, and font used in writing. You will have noticed that this daily cartoon includes speech bubbles, images and a caption under the cartoon. The cartoonist also used bright colours to show the cartoon is humorous, placed the most important character, Lionel, in the middle of the frame, and used facial expressions of the pride to show that they do not think Lionel is a typical lion. They actually look kind of cranky. Lionel's facial expressions, though, are much more friendly. This makes me think that Lionel might have a bit of trouble fitting in. As we identified earlier, the purpose of the daily cartoon is to entertain the reader. What about the text structure of the daily cartoon? This is a single event. It is a point-in-time event that does not require additional information. Do you think this is an effective daily cartoon? Do the images and the words go together to create an impression on the reader and achieve the purpose of the daily cartoon? I think that the author has combined the different language and visual features of the multimodal text effectively to engage the audience. Now let's look at the comic strip. Do you think it is an effective multimodal text? To make this judgment, think about its purpose, to entertain, and how it uses language, visual and audio features, as well as the text structure. How have the images and the words been used to entertain the reader? We may all have had different responses to how effective this multimodal text is. You will, however, have been able to identify that this is a multimodal text as it contains speech bubbles with images. The cartoon strip contains elements of narrative structure and uses an attempt at humour and bright images to engage the reader. We read and engage with many multimodal texts during the day. Sometimes these will be in print, other times these will be digital, and sometimes they will be like this TV show.
Hi, welcome back. It's now time for mathematics. Have you ever wondered what is less than zero? Can you think of some places in everyday life where you see numbers that are less than zero? What are they used for?
It's freezing in here. It's so cold. People are saying that the temperature is below zero. But what's less than 0 degrees? I've seen the weather reporter on the news talk about negative degrees, but what's that? Let's look at negative numbers, put them on number lines, and use these number lines to solve problems. The term negative number is used to describe numbers less than 0. Until now, we've always started number lines at 0, but we can use number lines to show that numbers have a value of less than 0. Let's look at this video and find out how.
Integers on a number line. Look at this number line. 0 has been placed in the middle of the line. We know the numbers to the right of 0 are the counting numbers. These are also called positive numbers. But what about the numbers on the other side of 0? Did you notice that the numbers on either side of 0 are symmetrical? They are called negative numbers. The value of the numbers increase as you move to the right and decrease as you move to the left. The number line can also be written vertically. The numbers above 0 are the positive numbers, and the numbers below 0 are negative numbers. Numbers increase as they move up the number line and decrease as they move down the number line. The positive and negative numbers on a thermometer are also set out vertically. The positive numbers are above 0 and the negative numbers are below 0. Now it's your turn to use a number line to solve problems.
We've created a number line here with numbers already positioned. There's one number left to place, 0. I've been careful to make sure that the numbers are evenly spaced. On number lines, we increase as we move to the right and decrease as we move to the left. Because the negative numbers are less than 0, they're placed on the left-hand side of 0, still keeping equal distances between the numbers. Notice that 0 acts as a mirror for these numbers. Can you see how the positive numbers and the negative numbers are reflected around 0? Now, what's the number 4 spaces to the left of 0? I'm going to count. 1, 2, 3, 4. The number is -4. Is this number greater than or less than +4? Even though they're the same distance from 0, -4 is to the left, so it's got a value less than 4. So how many steps between -4 and +1? Let's count. 1, 2, 3, don't forget 0, 4, 5. There are 5 spaces between -4 and +1. So the difference between them is 5. We can use a number line to solve problems like our temperature question at the beginning. The temperature was 2 degrees Celsius at bedtime. The temperature fell 5 degrees overnight. What's the temperature in the morning? We start at +2. The temperature fell 5 degrees overnight. 5. In the morning, the temperature was -3 degrees. Let's count. 2, 1, 2, 3, 4, 5. The temperature fell 5 degrees. It was -3 degrees in the morning. Let's write a number sentence to show this problem. At bedtime, the temperature was 2 degrees. Overnight, it fell 5 degrees. In the morning, it was -3 degrees. 2 minus 5 equals -3. It's a bit later in the day and I'm feeling a lot warmer now. Today we used a number line to solve problems involving integers. They are positive and negative whole numbers including 0. Keep a lookout for other places you might see negative numbers. Maybe you could create a game using number lines. Perhaps you're an explorer who treks the mountains or dives the depths of the oceans. See you next time.
And good job, kids, solving problems on a number line in maths. It's now time for a special health message that will keep you on the right track. Take a look.
Hi, I'm Luke William and I compete in triathlon. I'm stuck at home just like you, so it's really important to stay active and healthy. Firstly, I make sure I try and eat healthy as I can so I can perform at my best. So that means I make sure I have lots of fruit, veggies and grains, and I always make sure I have a water bottle on me at all times. Secondly, I need to take care of my body, so I make sure I have a shower every day, put sunscreen on when I go outside, wash my hands every time I go to the bathroom, and if you're feeling sick, make sure you tell an adult. My favourite way to be healthy is to keep active, and so I make sure I do 60 minutes of exercise every day. And I love to go for a swim, a bike and a run. Let's think about how we can be healthier at home. Does that mean going and having a little break and doing some activity, or having a healthy snack in between lessons? Remember to have healthy habits every day. See you next time.
The study of space is called astronomy. In a town called Parkes in New South Wales, there is a huge telescope that helps scientists to observe different parts of our solar system, some of the largest and smallest bodies in our galaxy. Today in Science, we will explore our solar system too and learn about the relative size of the planets and the distance between them. Here's Monty with more.
Did you know that there are over 500 different solar systems in the Milky Way galaxy, including ours? Today, we are going to explore our solar system. Our planet Earth is one of 8 planets that move around or orbit the Sun, and that's why it's called a solar system. Some scientists refer to Pluto as the 9th planet, and there is some debate between astronomers over this. The planet closest to the Sun is Mercury, followed by Venus, Earth, Mars, Jupiter, Saturn, Uranus, and finally Neptune, which is furthest from the Sun. Have you ever wondered how big Earth is compared to the other planets in our solar system? Well, there are a few ways we can think about this. If we measured Earth's diameter by using a straight line from one side of the Earth through its centre to the opposite side, it would be 12,800 kilometres. And that's 3 times the width of Australia. In comparison, Jupiter's diameter is 143,000 kilometres, and that's more than 11 times as large as Earth's diameter. These numbers are so big, it is difficult for us to visualise them. To help us visualise these sizes, we can shrink these numbers down into sizes we are more familiar with. We can use everyday objects in a scaled model. Scientists use scaled models to accurately represent the relationships between objects on a smaller scale, or even on a larger scale, like if we want to talk about cells or other really small objects. Today, we are going to use fruit and vegetables to represent the planets in our solar system so that we can visualise the size of the planets relative to each other. We can see each fruit and vegetable is a different size. If we allocate a fruit or vegetable to a planet, we will be able to compare these sizes. Let's start by using a cherry tomato to represent the Earth. If Earth was the size of a cherry tomato, then Mercury would be the size of a peppercorn. Venus would be a large blueberry, and Mars would be a pea. Jupiter would be a watermelon because it is so much larger than all the other planets. Saturn would be a rock melon. Uranus would be about the size of a grapefruit. And Neptune would be a lime because it's smaller than Uranus. Okay, let's take a look now at all our planets. Using our model, which planet is the smallest and which is the largest in our solar system? Mercury, the peppercorn, is the smallest planet, and Jupiter, the watermelon, is the largest planet. Now that we have found a way to represent the relative size of each planet, we need to find a way to represent how far away each planet is from the Sun. Now, the solar system is so big and vast that it's hard for us to visualise. We can also show large distances using scale models. We do this by representing something large with something smaller. For example, what does 20 million kilometres look like? It's so large, it's difficult for us to visualise. What if we represented 20 million kilometres with 1 square of toilet paper? This way we can create a scale model of the solar system to show the distance of each planet from the sun. Boom! With the magic TV, here I am, and I've set up a scale model for you to show you the distance between the sun and the planets. The sun is this first yellow cone, and you can see the first 4 planets, Mercury, Venus, Earth and Mars, are really quite close together. Come with me. All right, here I am at Jupiter. This is Saturn. Whoa! Look how far away Uranus is from the sun. And all the way down here, I'm at Neptune. I had to use 229 squares of toilet paper to show how far away Neptune was from the sun. And because this is a scale model, that represents 4,448 million kilometres. That sort of size, it's astronomical. Let's recap what we've learned today. We now know that our solar system contains 8 planets that orbit the sun. Mercury is the smallest planet and Jupiter is the largest. Scale models are used to help us visualise and compare large numbers like the size of planets and the distances between them. Now it's your turn. This afternoon you might like to create your own scale model of the planets. This could be a drawing or a physical model like this. To create your model, you could use everyday things found at home. Try to remember the order of the planets. See you next time.
Thank you, Monty. Wasn't that interesting? I don't know about you, but now I really feel like eating some fruit. And we can because we have finished our Learning at Home TV lessons for today. I've really enjoyed it. Remember that we are all back with you every Monday, Wednesday and Friday, and we have plenty more fun and learning to share. So until next time, stay safe and positive and make sure you look after each other and continue to wash your hands and follow all the good health messages that you've heard today. Bye for now.